Happy Wednesday, everybody. We're continuing with topic 7 review. We're going to look at prime and composite numbers today. So it's taking sort of what you did on Monday and what you did on Tuesday, listing factors, and now determining if numbers are prime or composite. So prime numbers only have two factors, one and that number. Okay, so 5 is a prime number because the only factors of 5 are 1 and 5. Composite numbers have more than two factors. Okay, so 6 we've used as an example the past couple of days. We know the factors of 6 are 1 and 6, and then 2 and 3, right? So it is a composite number. All right. Using sort of your knowledge of listing factors and your multiplication facts will really help you today. And also, when we get to larger numbers, you're going to have to use a little bit of reasoning. So let's just review, and it's good to go back and look at the arrays to help sort of just build the foundation of prime and composite. So if I were going to make the arrays for the factors of 5, which are 1 times 5 and then 5 times 1, the arrays would be 1 times 5 and 5 times 1. So look at the arrays that are made for 5. There are only 2 arrays, right? And each array either only has like 1 row or 1 column. Okay, so this is a prime number. So another way to think of prime numbers is that when you make the arrays, you're only going to end up making 2 arrays. And those 2 arrays are only going to have either 1 row or 1 column. If you look at all the factor pairs for 6 and the arrays that go with them, so 1 times 6, 6 times 1, 2 times 3, 3 times 2. Notice you have a greater number of arrays in a composite number. Not just 2 arrays. So that's another way for those of us who are sort of more visual and need to see the concept a different way. So just a reminder, prime numbers are numbers that only have 2 factors, one in itself. An example, like I said before, is 5 is a prime number because it only has 2 factors, 1 and 5. Composite numbers are numbers that have more than 2 factors. Another example of a composite number is 12 because it has 1 times 12, 2 times 6, and 3 times 4. So looking at the questions today, there's a lot of just yes or no questions. So I just took some questions from the book and we'll sort of talk them out and just yes or no. So the first question here, what is the only even prime number? And I know my class and I, we spent a lot of time on it. The only even prime number is 2 because the factors of 2 are 1 and 2, okay? Here too, write an odd number that is not prime. So a lot of people get confused because there are after 2, which is the only even prime number, all the other prime numbers are odd numbers, but that doesn't mean that every odd number is a prime number, right? So 9 is an odd number, but it's not prime because it has the factors 1 and 9 and 3 times 3, right? 15 is an odd number, but it has the factors of 1 and 15 and 3 times 5. So just, it is a common mistake. Oh, that was my 5. But all odd numbers are not prime. After the number 2, the numbers that are prime are odd, but not all odd numbers are prime. Roger has 47 cars. Can he group the cars in more than 2 ways? So what they're really asking you is 47 a prime number or not? So I know my multiplication facts, and I know none of my multiplication facts are going to get me to 47. I know if I count by 3s, after I get to 3 times 12, which is part of my facts, is 36. I'm going to count by 3s to see if 3 is a factor of 47. So 36 plus 3 is 39. 39 plus 3 gets me to 42. 42 plus 3 gets me to 45. 45 plus 3 gets me to 48. So 3 is not a factor. So actually 47 is a prime number. So no, Roger cannot group them in more than 2 ways. He could just do 1 times 47 and 47 times 1. Okay? So again, notice how I did sort of thinking aloud and some reasoning. As the numbers get larger, you're going to have to start thinking about multiples of numbers and sort of how you can determine if a number is prime or not. So tell whether each number is prime or composite. You can put a P or a C. 32, I know, is a composite number because it's an even number, 32. 16 times 2 is 32, so it's composite. 51, the other day we said 3 times 7, 17 was 51, so I know it's composite. 73, I know is not part of my multiplication facts. I know if I do multiples or skip counting of 3, 66 is 22 times 3. So if I add 3 to 66, I get 69. If I add 3 to 69, I get 72. So 3 is not a factor of it. 4 is not a factor because we know 4 times 20 is 80. And if I subtract 4 from 80, I get 76. If I subtract 4 from 76, I get 72. So 73 is actually a prime number. 21, 3 times 7, so it's composite. 95 ends in 5. Anything that ends in 0 and 5 has 5 as a factor, so it's composite. And 29, I know my multiplication facts. It's odd, so it can't have 2. I know 27 is 9 times 3. I know 4 times 7 is 28, so this is prime. Okay? Let's try a couple more. So here they give us the arrays. And again, they're just asking if it's prime or composite. 7 only has 2 arrays, so I know it has to be prime. 10 has more than 2 arrays, and it's also even, so I know it's composite. 12, I know 2 is even, so 2 times 6, but also 3 times 4, so it's composite. 97, if I think of skip counting of 3, it's not going to get me there. If I think of skip counting with 4 after 80, be 84, 88, 92, 96. Nope. 97 is a prime number. 90 has 10 as a factor, so it's composite. 31, I know my multiplication tables. I know it's not even. I don't know anything that gets me to 31. It's going to be prime. 11 is not even. I know my multiplication tables, and nothing's getting me to 11, so that's prime. 44 is even. 2 times 22, also 4 times 11, so it's composite. 3 is a prime number. Its only factors are 1 and 3. 59, let's think. If I do 3 times 20, I get 60. So 3 isn't. 4 I know isn't because 12 times 4 is 48. And if I add 4 to 48, I get 52. If I add 4 to that, I get 56. If I add 4 to that, I get 60. It's not 5. It's not 6. So it is prime. Okay? So boys and girls, today you're just working on prime and composite. It's just going to ask you to name them. I will see you tomorrow, and we'll review multiples, and then you'll have the challenge on Friday. Okay? Have a great day.